So in this problem, we're given that the product of 1 plus cosine alpha, 1 plus cosine beta, and 1 plus cosine gamma, that's equals to 1 minus cosine alpha times 1 minus cosine beta times 1 minus cosine gamma. This is given. Then we need to show that one of the values of each member of this equality is sine alpha, sine beta, sine gamma, the product of these three sine functions. So let's begin. So we'll start with whatever we've been provided with. So here we have 1 plus cosine alpha multiplied to 1 plus cosine beta times 1 plus cosine gamma. So that's given that this is equals to 1 minus cosine alpha times 1 minus cosine beta times 1 minus cosine gamma. What we will do, we're going to multiply both sides of the equation with 1 plus cosine alpha, 1 plus cosine beta, and 1 plus cosine gamma. On the left hand side, we will get square of each of the expression, 1 plus cosine alpha squared. Now here we're going to have 1 plus cosine alpha times 1 plus cosine beta times 1 plus cosine gamma, which will be equals to, now we know that 1 minus cosine alpha times 1 plus cosine alpha, that's simply 1 minus cosine squared alpha. So here we are using the fact that whenever we have the product of a minus b and a plus b, that's actually a squared minus b squared. So we are using this fact. So we can also combine 1 minus cosine beta with 1 plus cosine beta. So that's going to give us 1 minus cosine squared beta. And finally, we have 1 minus cosine gamma times 1 plus cosine gamma. So that's 1 minus cosine squared gamma. Now we are going to use the standard identity. We know that sine squared theta plus cosine squared theta, so that's always equals to 1. So that means sine squared theta can be also expressed as 1 minus cosine squared theta. If we replace theta with alpha, then we'll get 1 minus cosine squared alpha will become sine squared alpha. Then in the next case, if we replace theta with beta, then 1 minus cosine squared beta will give us sine squared beta, and similarly 1 minus cosine squared gamma is going to give us sine squared gamma. Now we have squares on both sides. So if we take the square roots on both sides, we're going to get 1 plus cosine alpha multiplied to 1 plus cosine beta times 1 plus cosine gamma. So this will be equals to sine alpha times sine beta times sine gamma. So we have shown that each of the values of the members of 1 plus cosine alpha, 1 plus cosine beta, and 1 plus cosine gamma, that's the product of sine alpha, sine beta, and sine gamma. The other way around, so what we did here was we multiplied both sides with 1 plus cosine alpha, 1 plus cosine beta, and 1 plus cosine gamma. Now if we do the other way around, that means multiplying both sides of the original equation with the expression on the right hand side, that is 1 minus cosine alpha, 1 minus cosine beta, and 1 minus cosine gamma. We're still going to get sine alpha times sine beta times sine gamma.